Mr. Waller, the science teacher. Teaching the lyrics. Mr. Waller, Mr. Waller, your science teacher. Graphing snap pretty weird for second square. That's cause environmental damage.
Alright guys, welcome back. Hopefully you picked up on my little Pikachu Easter egg in the video. If you don't know, he's an electric Pokemon since we're talking about current electricity in this unit. Yesterday I put your current electricity notes back on Google Classroom in case you lost those from before the break. What we're going to do today is we're going to do first a short little quiz to see if you know what has electricity and what doesn't have electricity in it. Then we're going to hit the high points in the notes, whether it's current, voltage, amperage, parallel, series, all the major things in the notes so you guys feel refreshed on it. And finally, I'm going to have building a circuit video with y'all. I'm actually going to show you the difference between parallel and series in person. Well, not in person, but digitally. You guys get it. So anyways, I'm excited to do this, but guys, let's first get started with this little quiz. Here we go. All right, let's check out this breaker box. I don't know. Man, you think that's got electricity in it? Oh yeah, that's definitely got electricity for sure. Good job, guys. Is there electricity in that dog? No, that's a dog. What about in that sign? Yep, it's a sign. There's electricity in it. Come on, it's an electric sign. Get it together, guys. What about in that duck and that mud hen? Nope, those are birds. Guys, what about my truck? Let's see. Does my truck have electricity in it? I don't know, man. Let's find out. Oh, I don't know. Yeah, that's definitely a battery. Yup, definitely got electricity in there. That's a diesel. But yeah, that's the battery. For sure, electricity. Is there electricity in that Ram? No, because that's a sheep. What do you guys think about those traffic lights? Electricity, no electricity? Yeah, they got electricity, for sure. What about in that cow? Nope, that's a cow. What do you think about my laptop? Ooh, hacking into the system. Yep, electricity, for sure. Hey guys, how'd you do on the quiz? Did you know that cows had no electricity in them? I didn't. Guess we're both learning something. Guys, first, welcome back. Officially, we're in class. This whole video, it's new, but welcome back. Fifth period, I'll make things normal with y'all. Annalisa, why are you late? Todd, why are you being so Todd? Gianna, get off your phone. That feels better. Seventh period, let's see. Bonnet, late again? I'm gonna email the softball coach. Tyler, every day you're late, dude. Come on, get a tardy pass. Eighth period. Guys, stop talking, please. Bronson, nice helmet hair. See? We're back to normal. Okay, so, guys, let's quickly go through some of the notes that I sent y'all. Okay? We've talked about them way before break. I sent them to you yesterday, but just in case you need a little more clarification, I'm making a short video. Alright, that's attached to everything else. After this, we're going to build circuits together. Okay, so let's hit the high points. Okay, we have current, we have voltage, and we have resistance. Okay, three different parts of electricity that all come together. So let's break this up a little bit. Let's talk about current first. And I'm going to try to write large enough that y'all can see this. This is my second attempt making this video. I did the first time and realized I had half the board cut off because I'm using a ladder and a thing of chainsaw oil to prop up the camera. Okay, so yes, we have current. And someone just ran by jogging. You can hear their music. I apologize. Guys, current. All right. We have voltage. And then we have resistance. Okay. Guys, underneath these names, I'm going to put the unit for these. All right, guys, current. The joke I always said was rhymes with lamps. Okay, amps. So our unit, okay, unit amps. Amps, short for amperage. Voltage, it's in the name, volts. So the unit, volts. Resistance, told you, it's essentially when a old school monk is praying. So ohms. So our unit for this is going to be ohms. O-H-M-S. So current is amps, voltage is volts, resistance is ohms. Okay, guys, think about, no, I mean, not think, you don't have to think about it, but the example I used was electricity is very much like a river. It's like a flowing river. Okay, when you get in the river, you might get pulled by the current because it's really strong. It might be a very weak current. As you trying to fight that current, you trying to go upstream, you're resisting the flow, right? So let's make this easy to understand. Okay, current we said is amps, voltage is volts, resistance is ohms. But what is the normal person's definition of all this stuff? Current is going to be the flow of electrons. The flow of electrons, okay? You're in the river, you get in, the current takes you away. Okay? The electrons flowing through a wire, that is your current. That is your amperage. That is your amps, alright? Voltage, okay, is very, very similar to this, but I use the example back before break, like going to Schlitterbahn. If you've been to the newer part of the park, they have that wave pool. It's a giant ring. If you get close to the wave generator, it takes a few seconds, but it pushes out a giant wave, okay? The bigger the wave, the faster you go, and it makes the current feel stronger, but it's not current, guys. So voltage is the push of the electrons, okay? So that wave generator at Schlitterbahn is essentially, the more wave, the more push you get, the faster you flow through the current. So voltage is going to be push of electrons. Okay? Flow, current, push, voltage, volts. Last one is resistance. It's pretty self-explanatory. It's in the name. To resist means you're fighting something. Okay? Resistance, if we want to go with our notes definition here and try to make it into something easier to understand, because I can explain it, but sometimes kids, they get a little bit confused with it. It's essentially, in the notes, it's saying the tendency for a material to oppose the flow of electrons. And all materials have some resistance, like wood and metal. They both allow electricity to flow through them, but metal allows electricity to flow better, so it has a very low resistance. Wood, you get enough electricity flowing through it, it's going to burn. So it has a very high resistance. It heats up instead of letting electrons flow through it. So I like to put resistance is basically, you guys, fighting electron flow. Okay, so current, the flow itself, voltage is the push of the electrons, and resistance is fighting the electron flow. So again, wood has a higher resistance than metal. Wood burns, metal, when electricity flows through, it doesn't burn, but it'll shock you if you touch it. So those electrons are flowing through, much easier than they're trying to flow through wood. And the notes also went over things like solar panels, thermocouples, generators, all that type of stuff. Guys, you use a generator in case your power goes out. You use solar panels to turn sunlight into electricity. You can use the thermocouple to turn heat energy back into regular electricity. Like imagine a charger, but instead of being like solar powered or something like that, it's essentially you put it by a heat source. Like let's say you're camping, you put it right by your fire, not in the fire, but near your fire. It's taking that heat energy and turning it into electricity to charge your phone or other device. A couple of things I want to hit on, guys. We have two types of electricity. We have DC and we have AC. Okay, DC and AC, just like the band, but I got them reversed here. DC is direct current, and again, this is in the notes, but I'm just trying to hit our high points here in case you're a little bit confused. AC is the opposite of direct. Direct means one way, one direction, like that lane band. Guys, AC is the opposite of that, so it alternates. So this is alternating current. Okay, in our notes it says that DC electricity Okay, things like batteries. Okay, there's different kinds of batteries. There's wet batteries, there's dry batteries, all that stuff. Guys, DC, you store electricity in DC sources, like your car battery, like your phone battery. If your phone battery goes out, you need to charge it up. It lost its, lost electricity in there. The batteries in your remote controls and things like that. AC, or alternating current, is the electricity that we have in our walls when you plug something in. When you plug that charger in to charge your DC battery, it is, what's powering up your TV, your computer, your laptop that's probably charging right now, your refrigerator, all that stuff. Okay, so DC and AC. And in the notes, and I showed you guys a couple videos, we talked about Thomas Edison, Nikola Tesla. Thomas Edison, inventor of the light bulb, not really. His whole thing was DC electricity. If it was up to him, we would have giant batteries all over the U.S. to power our homes. That's kind of ridiculous. Nikola Tesla was all about AC. Okay, much more efficient, and Thomas Edison behind DC didn't like that AC was getting so much publicity, so he bought an elephant named Topsy from an elephant and electrocuted it to death using AC to scare people away from it. I showed you guys the video from way back in the day. Thomas Edison, he was kind of a jerk. Okay, so guys, again, current, voltage, resistance, DC, AC. All right, home electricity, what's powering your home, batteries, your car, your phone, all that stuff. Okay, and the last thing that we're going to look at is, let me get my little Clorox right here, because it's really the only thing that's good at cleaning this right now, because I have my Expo spray. This is awkward. If I knew how to edit videos, I would totally edit this out. Guys, I'm going to get rid of DC and AC if that's okay with you, just because I need the space. Okay, so let's talk about circuits themselves, what we're going to be looking at in a video in a little bit. Okay, we have two types. We have series and we have parallel. Series is a very, very simple circuit. Parallel is a little more complex. Okay, a series circuit, that simple circuit, is like what is in these. Okay, the old school Christmas lights. In these lights, if one light goes out, everything goes out. This is not what we have in our homes. If your blender goes out, your whole house doesn't shut off. Okay, so this is a very, very simple baby circuit. When we talk about parallel, parallel is like a bunch of series put together with multiple pathways. So if something goes out in a parallel circuit, everything else can stay on. Okay, if your house, again, if your blender goes out, your house doesn't turn off. Okay, because there's multiple pathways for electricity to flow through. And let's see if this is dry enough. Not quite. Do I have anything to dry off with? This is not expected, and I'm stupid. I'm gonna take my sock off because I don't want to have to pause the video. So guys, don't judge me. It's COVID-19. We're making this work. All right. Forget about the sock. Anyways, so let's draw some sample series and parallel circuits. Okay, so let's look at a series right here. We're going to look at parallel. I always forget how to spell it, but it's one R and two L's in the middle. So we've got series, we've got parallel. For both of these, we're going to have a battery source. Let's just focus on series right now. Okay, battery, which is DC. Okay, here's my battery. Okay, I'm going to have a couple light bulbs. Let's say I have a light bulb right here, a light bulb right here. I said a couple, I lied, we're going to give it 3. And let's add a third light bulb right there. Okay, I have 3 light bulbs, 1 battery. I'm going to have a wire connected to my first light bulb, connected to my second, connecting to my third, and all the way back to my battery. That is a terrible looking series circuit, but we see it as a simple pathway. Guys, circuit means circle. It is a constant flow from one end to the other. The circle is complete. Just like our janky Christmas lights, if one of these light bulbs, if it goes out, the rest of them go out. Guys, if this filament right here in the light bulb burns up, it gets overheated, you've broken the circuit. Electricity will flow through this light bulb and stop right here. Because it stops, it cannot go back into the battery. You don't have a complete circuit, so all of these light bulbs burn out, meaning if this guy goes out, everything goes out. This is not what we have in our house. This is our cheap Christmas lights. Let's go to parallel. Okay, very similar. We've got our battery, okay, and we're gonna have multiple light bulbs. Five to be exact. Okay, so I've got my wire, and I'm gonna make it real fancy like this. Okay, got wire, nothing's connected, so you're questioning how's it gonna work? Well, we're not done yet. Okay, so from here I'm gonna have all these different paths. Okay, all these different pathways for electricity to flow through. Do one right there, and let's just do I don't know, it doesn't matter. Hopefully you guys can see this again. My camera was messed up the first time. Okay, guys, so we have all these different pathways, right? This is very, very complex. It's like in your house, okay? All your rooms connected, all the stuff in your car, the circuits in your cars, like your windshield wipers, your power locks, power windows, all that stuff, everything, your radio, everything kind of hooked up like this, okay? If this light bulb burns out, that doesn't shut everything off, because electricity, and let's add another pathway, flowing this way, it can't flow that way anymore, but it can still flow through all these other pathways. Okay, the more pathways, the more likely that your parallel is going to stay on. The other resistors, the other light bulbs, the other fans, motors, whatever, the more pathways you have, the safer it is. Okay, even if you were to burn out this guy here, it's not going to shut everything else off, because electricity can flow through multiple different pathways. Again, this is in your house. Okay, series is simple, parallel is a little more complicated. I'm going to end this part right here, and the next thing we're going to do is we're going to build some of these circuits together. All right, guys, so we're finally going to get to build our circuits. And normally if we were in school, I'd have a bunch of these, and you guys would be able to group up and build your own circuits. It's got all these cool pieces, but sadly we're doing this digitally. So let's take a look at what we have. We have all these cool looking pieces. They have little snap together sections. But we're going to go through most of these pieces and talk about what they do, and again, get into those simple circuits. So first, let's look. We got this thing right here. It kind of looks like a pegboard. It's transparent with these hexagons in the middle. This is what we're going to be building our circuit on. It is very much like a Lego. All of these pieces snap on. Yes, this is a fan blade. Okay, it goes along with this motor right here. You put the fan blade on top. We have a little speaker, a little siren. We've got a light bulb. We have these blue pieces here that are various sizes. These are all what are going to be our wires. Okay, you're probably wondering, well, they don't look like wires. Okay, on top, like I said, we have these little snap pieces. Okay, if the camera will focus, right about there. But if you flip it over, okay, we have metal running underneath all of these. So this is essentially an invisible wire. Okay, so what we're going to get started with is we're going to build our series circuit first. And a series circuit, like I said, is a very, very simple circuit. It's like those cheap Christmas lights where if one thing burns out, everything shuts off. So the first thing we're going to need is a power source. So I'm going to come over here, I'm going to grab this bad boy. This is going to be our power source. Okay, and I'm going to snap it into place. Okay, and guys, it is missing batteries. So what am I going to do with that? I'm going to take two AA batteries, Energizers. I'm more of a Duracell guy myself, but we're going to make it work. Okay, so I now have my energy source, my power supply snapped into place. And again, we're going to make a very, very simple circuit. So let's use a light bulb. So I'm going to take right here this guy. This is for my light bulb. Going to snap that into place. You're probably wondering, well, there's no bulb. I've got one right here. So we're going to take our bulb, carefully screw it in like so. And what I'm missing now is my wires. And if I look, I have 1, 2, 3, 4, 5. I have 5 spaces in between. So what I'm going to have to do is find a 5 wire. And you'll see this wire right here has a 5 on top. So I'm going to take this apart, and I'm trying to do this with one hand. Okay, got 1 5 there. And what else do I have here? I have, a 7, a 2, a 6. You know what, instead to make this easier on me, because I have 2 4s right there, I'm going to take this apart, bring it 1 position closer, okay? Gonna get rid of these wires because they're not gonna do me any good at the moment. And I'm gonna take my 4s out. Again, why am I taking the 4s? Because there's 1, 2, 3, 4 spaces in between. All right, to complete the circuit, we need to have a complete pathway. Right now, there's no way that our battery can power up this light bulb. So what I'm gonna do is I'm gonna take, again, that wire, I'm going to connect these, like so, and again, snapping in place, okay? So what I'm gonna do next is I'm gonna take my second wire and I'm going to complete my circuit. And this should turn, oh, look at that. Haven't even clicked it in and it wants to turn on. And guys, that is a very, very strong light bulb. Let me turn off the light so you guys can understand what I'm talking about here. Yeah, still got another light in my house, but guys, I have completed my path and my light bulb is on. If I break my path, my light bulb turns off because electricity cannot flow, it cannot complete the circle. But again, fixing that. So that is our basic series circuit. And this is the simplest one. It has 1 resistor, guys, 1 light bulb. But let's make it a little more complex. We're not gonna make it parallel yet, but we're gonna make it a fancier series. So I'm gonna take this all apart, okay? And let's first make sure that our fan motor works. Okay, so here's my fan. Okay, I'm going to take my little fan actual piece that fits on it, the propeller, whatever you want to call it. Okay, I'm going to connect 1 wire and let's see what happens when I connect the second one. Look at that, having it snapped it in place. And guys, you can't feel it, but this thing would be very nice on a hot summer day, just putting out a lot of wind, if that makes any sense. And I haven't even snapped in place, guys. Look, ooh, was not expecting that. That thing flew off. Okay, so let me do that one more time and actually click it in. Whoops, up. Dang, that thing's got some power. So we know our fan works, right? Great. So taking everything apart, again, we're gonna make that fancier series circuit. So what I'm gonna do is I'm going to put my, let's see what I got here. I'm gonna put my light bulb here, and I'm going to put my, yeah, you know what? We're gonna play around here. I'm gonna put my fan over here just to give it some space. And what I'm gonna do is I'm gonna make some small connections here. I'm gonna start putting it together. So I have a 2 that clicks in, and what I'm planning on doing is connecting my power source to my light bulb, bringing it to my fan, back to my power source, completing the circuit. So I have a 1, 2, 3, 4 space. So I'm gonna put a 4 like so, okay. Popped in, and this is gonna get a little weird. Let's see if I can make this work with a 2. Nope, not quite. So here's what I'm gonna do. I'm gonna take one of these little single pieces. These are really convenient. So what I'm gonna do is I'm gonna build a little corner. So I'm gonna pop this bad boy in place. Okay, I'm gonna take a 2 connecting to that one I placed underneath there. And before I do this, before I complete my circuit, I'm gonna place my fan back on top, okay? So now all I need to do is, actually more than just that, I need to put one more here to raise the level up, okay, just like Lego pieces. And what I'm gonna do now is I'm gonna complete my circuit by placing a 2 on here. All right, so when I do this, we should have our light bulb turn on and the fan turn on all at the same time. Look at that. Okay. Guys, I can tell you right now, just being around this fan, it's not going as strong. It doesn't have as much power as it did before. And that's because the light bulb is drawing some power and the fan is drawing it. So the light bulb isn't burning as bright and the fan isn't turning as fast, okay? And remember how I told you this is just like those cheap Christmas lights? If one thing goes out, everything else goes out. So let's see what happens when I remove one component. I'm gonna remove my light bulb because it's gonna be easy to unscrew, okay? Look at that. My fan turned off. Why did it turn off? Because the light bulb, it's hard to see, but inside of there, and don't judge my gross nails, guys, there's a little wire filament that completes my circuit. And by removing it, I have broken the circuit. When I screw this bad boy back in, I will complete the circuit. This is like turning on a switch, essentially. And look at that. So this is our fancy series circuit. All right, the last thing we're gonna do is we're gonna build a parallel circuit. So I'm gonna take all this apart, okay? Shutting everything off, gonna remove my fan just so I don't get hurt. It's not gonna hurt me, but just to be safe. Taking this apart, okay? Taking all my pieces like this. And parallel, we know, has multiple pathways, multiple branches. So let's make this a little bit different, okay? So I'm changing the formation of everything here, okay? So I now have my light bulb and my fan over here, and let's start connecting my pieces, okay? I have 3 here and 4 here. You know what? Let's come over here. Let's grab a 3, if I can get that out of there. Oh, here we go. This one's much easier to get out. I say that and it's not. Okay, I'm gonna separate this out. Going to connect this guy to there, okay? And I'm gonna connect this guy to there, and you'll probably say, well, hey, you just made a series circuit. Yes, I did, but we're not done. Right now, power from the batteries to the light, and that's it. But I also wanna power my fan, okay? And this is gonna be different than what we just saw, because beforehand, electricity could only flow through one single path. But now we're gonna have multiple branches. So what I'm gonna do is I'm going to actually put a single one on here, okay? Because I need to get these at the same level. And I'm 1, 2, 3, 4 apart for each of these. Actually, before I forget, I gotta get my fan on, okay? And gonna connect there, and my last piece, let's see. Oh, it's already working, it hasn't been clicked in. Okay, and you can hear that fan is going fast. So let's check to see if this is a true parallel circuit. If it is, I should be able to remove one of these things, like let's say the light bulb, and the fan should stay on. Remember before, I removed the bulb and the fan turned off. So let's find out. Yep, still works. So, guys, this works because there are multiple pathways. So electricity can flow from here, through the light bulb and back, from the battery, through the fan and back. So if I remove this one component, the fan can still stay on. All right, this is just like in our houses, in your cars, you have multiple pathways. I'm sorry guys, that's a really loud fan. Let's see, there used to be this trick we would do with this. Let's see if I can bump it up. Oh yeah, that thing actually flies. All right guys, I'm gonna turn this off because it's getting a little loud. Look at that, shut it off. My light's still on, I'm gonna shut that off. Okay, so that completes this whole long video I've been making all day about series and parallel circuits. I hope you guys were able to, take away something from this by being able to actually see it put together. And I really wish I could do this with y'all because it's a lot of fun. And there are many, many really, really complicated circuits that we can make with this. Really fancy. I mean, you can only see a little bit of this because I had duct tape on here and it tore it, but we can make some really just intricate circuits. So maybe one day in the future. But guys, I'm going to be signing off here and hope, you learned something. And I plan on posting a quiz tomorrow. So please go through the notes and make sure that, you take away something from this video. You guys have a good one. Bye.